Alright, what's up guys? So we're starting Unit 10, which again is going to be everything that has to do with probability. So two things we're going to learn about today is something called a permutation and a combination and how it works with probability. So of course the first definition that we have is a permutation. So when a group of objects or people are arranged in a certain order, I want y'all to remember that. Permutation is in a certain order. The arrangement is called a permutation. So I want y'all to make sure you remember that permutation means the order does matter. So the next definition that we have is an arrangement or listing in which the order does not matter. It is not important, is called a combination. So make sure you remember permutation, the order does matter. Combination, the order does not matter. And then our last definition, this is going to come in handy whenever dealing with permutation and combination inside the formulas, is something called a factorial. A factorial is written as an exclamation point. So whenever y'all see it down low, whenever we work some problems here in a second, you'll see an exclamation point that's known as a factorial. A factorial of a non-negative integer, meaning not a negative number, n is the product of all the positive integers less than or equal to it. So for instance, if I had 8 factorial, that means I'm going to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So real quick, the formulas. The number of permutations of n objects taken at r at a time is written as p parentheses n comma r. So basically, let's say that we have 5 letters, and let's say those letters are A, B, C, D, and E. And I want to take 3 of those. Then your n would be 5 because there's 5 letters, and if we wanted to take 3 of those, R would be your number you're taking out. So R is 3, what you're taking out. So that's what you would put over here in your formula, the permutation of 5 comma 3, because the 5 would be the N and the R would be the 3. So then with the permutations formula, you would end up taking n and plugging it in for the n's, and then take the r and plug it in for the r, and then solve it, and it would give you the number of permutations inside the problem that you're working on. So next, for combinations, you're going to do pretty much the same thing, but if you look here, the difference between the permutations formula and the combinations formula is there's this extra r factor here, and we'll talk about that later and what the reason for that. But again, let's say, for example, we had A, B, C, D, E again as our letters, and we had to choose out 3 of those, but we don't specifically want to know how many permutations there are. We want to know just the combinations. N would be 5, your R would be 3, and then you would end up plugging into the formula to make it work with the combinations. Down here it says sometimes permutations use the N with the P in the middle, R, and then N with the C in the middle, R. So like for instance, this P parentheses 5 comma 3 could be written like this. So permutation with 5 on the left and 3 on the right. Or it could be also written as a combination, so C with 5 on the left and 3 on the right. So just so you know, this is the N and this is the R, and this is the N and this is the R. So those are 2 different ways that it can be written. Okay, so now we're going to go on to some examples. So now I'm just going to show you quickly how to work some factorial problems, because this is going to help us to work out the formulas later. So we need to evaluate the following and show all the work. So basically 10 factorial, what that means is I'm going to take the number 10, and then I'm going to multiply it by every single number less than 10. So I'm going to do 10. So if I did 10 times 9 times 8 and so on and so forth and multiply all this out, that would give me 3,628,800. Okay? So now 8 factorial. So 8 factorial means I'm going to multiply 8 times everything below it. So if I multiply those all the way through, you would get 40,320. And then lastly, 4 factorial, what that means is I'm going to do 4 times everything below it. 4 times 3 times 2 times 1 is going to equal 24. So that's the way you can work it out longhand. So now, if you wanted to, with your graphing calculator, right underneath your enter button, you should see a button with a factorial sign on it. So literally all you have to do is put the number 10 and then type in that factorial and click enter, and then click enter again, and it should give it to you. So again, if I did this in the calculator and I did 10 factorial in the calculator, you would get 3,628,800. Okay, so 8 factorial, we did it above, is going to be 40,320, and then 4 factorial is going to be 24. And then if you actually in your calculator typed in 60 factorial, that means I'm going to do 60 times everything underneath 60, and you get a really, really huge number, and this number is going to be way too big to write down. But what I want you to do on your calculator, I want you to type that in and just see how big that number is. It's going to be way too big to write. So 60 factorial, okay? Alright, so now on number 3 down here, it wants me to evaluate the following, and it wants me to show all your work. So right now, remember what the P stands for is permutations. The 5 is going to be your N value, and the 2 is going to be your R value. So P stands for permutation. So literally all I have to do is write out the formula. So N factorial is going to be divided by N minus R factorial. So literally all I have to do is plug in N and R and then factor it out, and then it should work out to cross out here. So let's go ahead and do this. So N is going to be 5. 5 minus 2 is going to be 3. So you should end up getting 5 factorial over 3 factorial. And then what I'm going to do is I'm going to show you how this works out longhand. So remember, 5 factorial means I'm doing 5 times 4 times 3 times 2 times 1. So let's write this out and see how this works. If you look at this, how this works out, the 3 is going to cancel, the 2 is going to cancel, and the 1 is going to cancel. So the only thing left is 5 times 4. So that means this is going to equal 20 total, because 5 times 4 is 20. So you see how it kind of cancels out longhand? Okay. And so now down here, we're doing another permutation example. So remember, the 7 is your N, the 4 is your R. So let's plug it into our formula we see over to the left. So N factorial, so 7 factorial. And then I'm going to do N minus R, so 7 minus 4 factorial. So let's go and write this out. So 7 factorial, and then 7 minus 4 is going to equal 3 factorial. So let's go ahead and work this out. If you look, 3, 2, 1 and 3, 2, 1 will cancel out. So 7 times 6 times 5 times 4 is going to work out to 840. Alright, so now on the back side here, we're going to actually work out some combinations factorials here. So we have combination of 5, which is your N value, the number of items, and we're going to be taking out 2 of them at a time. So we need to figure out how many different combinations can happen with these 2 numbers. So remember, my formula is N factorial over N minus R factorial, and then times R factorial again. So literally all I have to do is plug in my numbers and work out my math here. So your N value is going to be 5. So now what I'm going to do is just write out the factorials, and we'll be able to see how it works out in the end. So if you look here, we have 3, 2, 1 and 3, 2, 1, and those are all going to cancel out because they'll just cancel by division. So if you look, 5 times 4 is going to be 20, and then 2 times 1 is going to be 2. And 20 divided by 2 is going to be 10. So that means out of 5 and 2, there are only 10 combinations. So then lastly, looking at D over here, we already did C here. Lastly, looking at D, we have 7, which is going to be my N value, and 4 is going to be my R value. So let's go and look at the different combinations here. So let's use the same formula. Write this out and see how it cancels out. So I'm going to do it. So now if you look here, 4, 3, 2, 1, and 4, 3, 2, 1 are going to cancel out. So 7 times 6 times 5 is going to work out to be 210. 3 times 2 times 1 is 6. 210 divided by 6 is going to be 35. So that means there are 35 different combinations that we can use with these 2 numbers. So now that we know how to do this longhand, now I'm going to show you how to guys use it with your calculator. So literally all you have to do in your calculator, if you want to get to either permutation or combination, you're going to click menu, click the number 5, and that's going to be for probability, and you'll see 2 is going to be for permutations, 3 is going to be for combinations. And literally you'll type it in how it shows here. So on A it shows permutations 8, 2. So inside your calculator, you'll go to menu 5, 2, and then it'll show up with P with parentheses just like this. And you'll type in 8, 2 inside there, and then click enter, and it'll show you there's 56 permutations. And then for B here, permutation of 10 items, and I'm taking 6 of them out at a time, would give me, that one that's kind of crappy, 200. Over here on C is going to be another permutation, so I would go menu 5, 2, which would be permutations. And then remember, you would get P with parentheses, and it would just be written as 7, 3. So when I click enter here, that would give me 210. Okay. So now remember down here for D, C is for combination. So you'd click menu 5 and then 3, and you type it in just as shown. And when you click enter, you should get 28. On E here, you should get combinations, and when you click in 10, 6, you should get 210. And then lastly for F is another combination, and you would type it in as C parentheses 7, 3. And when I clicked enter on that, that would end up giving me 35. Okay, and lastly, on our last two examples, we're going to be dealing with a real-life example of either a permutation or combination. So the easy part of this is going to figure out if it's a permutation or combination and then plugging in what I know. So on number 5, it says, a group of 5 teens went to a movie theater. They found a row of 7 empty seats. How many different ways can the teens be seated inside the empty row? So you need to ask yourself, does the order matter or does it not matter? So think, if I'm going to sit in these seats at a movie theater, we're going to figure out the different ways that you can be seated. The order does matter. So this is going to be known as a permutation. So I'm going to put a P there for that. So we have 7 seats. So this is going to be my number of items. So N is going to be N is going to be 7, which is the number of seats. And then there's going to be 5 of those taken up at a time. So your R is going to be represented as 5. So in your calculator, or if you wanted to work it out, you could write in P parentheses, your N is 7, 5. And if you went and typed this in your calculator and you clicked enter, there would be 2,520 different permutations, so different ways that you can order them because the order does matter. And so now lastly on number 6, the principal of RHS wants to start a peer mediation group to work with discipline problems. He needs to narrow down his choice to 6 students selected from a group of 9. How many ways can a group of 6 be selected? So if I had 9 students, and if I took 6 of those out of that, how many different ways could I make that into those 6 group of kids? So in this, the order does not matter, because if I took 6 students out of those 9, no matter how many ways I rearranged them, they're always going to be the same group of 6 kids. So it doesn't matter how I arrange them. So this is going to be known as a combination. So we're going to go put parentheses here because N and R goes in there. So in this, the number of kids is going to be 9. So N is going to be 9. And I'm taking 6 of those at a time. So R is going to represent as 6. So literally in your calculator, you could go type in 9, 6, and when you click enter, so menu 5, combinations, and I would do 9, 6. So there's going to be 84 different combinations of students, of 6 of them at a time.